Hello, I am going to use GeoGebra to visually explain why the three angles of a triangle add up to 180 degrees. And I'm going to start with a circle. A circle has 360 degrees. In this case, the center of the circle is point A, and if we draw the ray from B through the center of the circle, it forms a diameter and it cuts the circle in half. So there are 180 degrees above the diameter and 180 degrees below it. This, in fact, is true for any straight angle. In this case, the straight angle is BAD, and that diameter, that straight angle, has 180 degrees. I'm mostly going to focus above the diameter. So let's look at these two pieces of arc. These two colorful pieces of arc add up to 180 degrees. Again, because we cut the circle in half. I have colored in one of them a little bit green, one of them a little bit purple, and we can see that because they're above the diameter and they're half of the circle, these two pieces of arc add up to 180 degrees. In fact, the purple arc has the same degree measure as, let's see if I can get this right, the purple angle CAB. So the measure of the arc, the minor arc CB, is the same as the measure of the minor arc of the angle CAB, and the arc from C to D, the arc from C to D has the same angle measure as that central angle right there, also colored green. CAD, the angle, has the same angle measure as the arc CD. Well, we already know that the two pieces of arc add up to 180 degrees. So these two angles right here, north of the diameter, angle CAD and angle CAB, add up to 180 degrees. Let's talk about these congruent arcs. All right. There are two congruent pieces of arc here colored in green. Arc CD is congruent to arc BE for a big reason, because it shares the same central angle, angle A, and we know that it shares the same vertex at point A, and we know that vertical angles are congruent. So that central angle at point A forms vertical angles, and the vertical angles are congruent. And we know that the two arcs, CD and BE, are congruent arcs. All right, let's look at the triangle. There is a triangle north of this diameter. It's triangle ABC. And this triangle ABC has some angles we've already talked about. For example, angle A. I'm going to talk about those angles, C and B, right now. Let's quick look at them. These two angles are congruent because they intercept congruent arcs. And now I'm using a little bit of content knowledge here. Let's talk about the intercepted arc of the inscribed angle B. Right here at angle B, there is a vertex, and the two rays intercept this arc CD. Right here at angle C is an inscribed angle, and the two rays intercept the arc BE. These inscribed angles are congruent. We could easily have said that because of isosceles triangle. Triangle ABC is an isosceles triangle. It has two sides congruent, and therefore base angles are congruent. We also know that these two angles, angle C and angle B, intercept congruent arcs. So they're therefore congruent angles. I'm going to throw in a little bit of content knowledge. The inscribed angle is half of the intercepted arc. So angle C is half of arc BE. Angle B has half the measure of arc CD. And since we know that all of these are actually, well, that the two arcs are actually congruent, we know that the measure of angle BCE right up here is equal to the measure of angle CBD for a lot of reasons. We know that arc CD is congruent to arc BE, primarily because of vertical angles. And based on our content knowledge, we know that this angle here at B is half of the arc CD. And also, this angle here at C is half of the same arc. So I'm going to try to focus exclusively on what's above that diameter, BD. All right, if we can really look at that. What we actually know now is that the three angles of the triangle ABC add up to 180 degrees. We have angle A right here, and if we added this measure right here, the arc measure CD, that would get us to 180 degrees. And that's exactly what we did, because we added two congruent angles, B and C, that are exactly half the measure of the arc CD, or of the central angle CAD. Each of these two smaller congruent angles, C and B, is half the measure of this angle CAD, so that if we add them together, we get exactly the measure of angle CAD, and we know that the measure of angle CAD plus the measure of angle CAB adds up to 180. So this triangle, and I hope I haven't limited myself to isosceles triangles, but this triangle is proven based on a few simple principles of a circle. This triangle is proven to have three angles that add up to 180 degrees.